Hello, my dear students. Hello, everyone. Here we go for another part in the hydrostatics, talking about the pressure at a point inside a liquid and how it could be measured. If we take a look, we find that the pressure acts in any direction, in all directions as shown. In these directions, we had no certain fixed direction like that, and the pressure on a body is the same as the pressure on a volume of liquid that has the same shape of the body. Okay, let's move to the definition at the point inside the liquid. It is the average liquid's weight. It is the average liquid's weight which acts normal to unit area at that point. Okay, to make it much easier, we have to drive a formula to make it more easy for someone to calculate the pressure at a point inside the liquid. We gonna have a horizontal plate X like that of area A, like this part, okay, at depth H below the surface. Of course, we all know that the volume of anything is the area times height. For example, if we had a tube like this, the area times the length, and this length could be called a height. Then the mass equals the volume times density. If we substituted the volume with A times H, we'll get that the mass equals A times H times rho. And the weight, of course, you remember that the weight is the mass times the acceleration due to gravity, which is G, which was 9.8 or approximately 10 meter per second square. Then the weight will be A H rho times G. Knowing that the pressure is the force acting on a unit area and the force comes from the weight of the liquid divided the area, then the pressure must equal A times H times rho times G over A. Simply, we can simplify this equation to find that the pressure equals rho G H in case of the closed container, and in case of the open container, we have to add the atmospheric pressure, of course. Let's move to another part. The factors affecting is the depth, the density, and the atmospheric pressure, and the pressure increases by increasing the depth, of course. Keep in mind that the H in this rule is the depth, it's not the height. We had to conclude three main points: that the pressure affected by the density, the depth, the first one is the density, and the depth, as long as we are in the same planet from the free surface H. All points in the same horizontal level inside the same liquid must have the same pressure. The liquid that fills connecting vessels rise in these vessels at the same height as shown in this and in that, regardless their geometrical shape, apart from the shape of this and the shape of that. Okay. All rise to the same horizontal plane. Therefore, the average sea level is constant for all connected seas and oceans.